Hey guys, it's Mr. Keeney again. So today we're going to talk about our next section of notes, which is going to be measuring and classifying angles. When looking at our learning targets, a reminder, we're still building off of our undefined terms to develop our foundations of geometry. We are going to use proper notation for our angles. We're going to identify them. We are going to use angle measures and also a little bit of angle addition postulate today. So that should sound familiar because we have talked about segment addition postulate, and the 2 and 2 are very similar when we think about them. All right, so we're going to start off with just a definition. An angle is two different rays that have the same endpoint. So again, we're building off of the vocabulary we've always used. Rays, something we saw in our first lesson, and we will continue to see if we put two of them together at the same endpoint, we get that angle. All right, so example one, we're just going to get right to how we name them here. So give three names for the angle shown, then name the sides and the vertex. So here is the angle that we're going to talk about. Now, there is three ways we could name this angle. The first one is we're going to name it just angle E. And the reason why we can name it angle E is because the vertex is E. So if we ever name an angle just with one point, one letter, it's going to be the vertex. The vertex is that shared endpoint, that shared initial point of the two rays. So because of that, I can name it angle E. However, there's two other ways that we can name it. One way would be angle DEF, and the last way would be angle FED. So what I always tell students is you're following the points. So if I were to name it DEF, that means I'm coming from up top here and I'm going DEF. That would work. The other way I could name it is starting from the bottom, FED. But we always have to have our vertex in the middle. That is really the key here, because when we look at our picture, our vertex is that shared initial point. So that is what is in the middle where they meet. So in our notation, we'll do that as well. And I just realized, I don't know if I pointed with this out. This right here is the symbol for angle. So when I say angle, that is how I am notating with that. All right, now I've already brought up this quite a bit. The vertex is a point. The vertex is that shared point, which in this case is point E. And then our sides are the rays. So there is one ray right there, which I'm going to call ray. And remember, with our notation, the arrow is always going to go to the right. And I have to start with the endpoint or the initial point. So in this case, it's E, D. And my second side, so let me clear this one here. My second side would also have to start with E, because again, we are starting with our vertex or our initial point, and it's EF. So I would call the other side EF. So those are kind of the components of an angle. We have three possible names for it, and we can't use those all the time, what you're going to see in example 2. We have one vertex and we have two sides that are rays. So also a little practice on our notation there. All right, coming down to this one, example 2, name the three angles in the diagram. So I'm first just going to mark the three angles, then we're going to talk about, up here we had three different names, and now we're going to be limited on what we can call these three angles. Here's the first one I'm seeing, right here, and hopefully you guys can see that. There's another angle, I'm going to get creative with my colors here, this other smaller one here. And then the last one I'm seeing is this one that goes all the way across. So I'm going to start off by trying to name that bigger angle, the green one here. So the one specifically I'm talking about is this bigger angle here. If I were to name that angle, from the last example, you would say, well, Mr. Keeney, I have three possible names. I could name it angle B. I could name it angle ABD, or I could name it angle DBA. And see, we got a problem here. Two of those names are very, 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 very good. One name is not so good. So I'm going to put that on hold because let's talk about this red angle real quick. Because if I were to say, hey, let's name the red one, you would probably say, okay, well, if you are talking about this angle, Mr. Keeney, I could name it angle B because that's the vertex. I could name it angle CBD, and I could name it angle DBA. And here's where our problem comes with our names. These two angles, so both the green and the red, they are two completely different angles. They share some things, but they are not the same. But take a look at these first names we listed. That is our problem. So we cannot use that just one vertex letter name in situations like this where multiple angles could be called angle B. The reason why it worked up here for this angle is because there is no other angle there. So this name was completely fine. However, that name, I got rid of that. However, that name would not be fine if something else were to be added. And so let me show you. If I were to add this, then that would not, then this name right here would not be okay because I have extra array in there and I have extra angles involved. But we don't have to worry about that in that one, but this one we do. So kind of a long way around to say we are getting rid of those two possible names. So those are the two possible names for those. And then our third one is our smaller angle here. ABC would be one of the names, angle ABC. Or I could kind of flip that and I could do CBA. Before we move on, I just want to point out too that in all of this, every single angle that I named has B in the middle. And that is because B is the vertex of all of those angles. All right, so that's kind of a little bit about notation and naming our angles. Now we're going to talk about the different kinds of angles. So we have an acute angle, we have a right angle, obtuse, and we have a straight angle. I believe these are going to be things that you have seen before. So if we're talking about an acute angle, the measure of the acute angle is anywhere between, so it's going to be between 0 degrees to 90 degrees. So, and actually, let me maybe notate this a little bit better. So if it's going to be an acute angle, it's going to be greater than 90, or greater than 0, excuse me, and then less than 90. For a right angle, it is exactly 90 degrees. Exactly 90 degrees. Cannot be anything more, anything less. An obtuse angle is greater than 90. But at the same time, it's less than 180. And a straight angle is exactly 180 degrees. So to give you a little sketch of what probably would look like, here's what an acute angle would look like. Just one of the many examples. A right angle is exactly 90 degrees, and we do notate it with a little box. An obtuse angle. And then a straight angle is our third different way to kind of show a line. Now, for me, I'm going to go ahead here and add our notation because you know when it comes to our notation, I like to have our required points for array and for our angle. So always being correct as far as how we are notating our pictures. So if not, then I'm sure one of you guys would have pointed it out to me of Mr. Keeney. You did not notate those pictures correctly. So just examples, just a little bit of review on classifying. Okay, so now we're kind of shifting to measurement here. So angle addition postulate, this should be something that sounds familiar because it's a segment addition postulate. We talked about the idea of part plus part equals whole. So it says if P is in the interior of angle RST, then the measure of RST is equal to the sum of the measures of, and let's use our picture over here. So here's our picture. There's the angle they're talking about. And if I want to get the sum of the whole, I can actually split it into these two angles. So it would be the measure of angle RSP plus the angle of PST. So basically what I'm getting here is the formula, the equation. If I were to take this one first, measure of angle RSP plus this angle here, measure of angle PST, is equal to the measure of angle RST. So let me clear this out over here so that you guys can see a little bit clearer. And I also want to point out that I am now using a little m in front of it. And by it, I mean the angle symbol. That little m means measure. So if I'm talking about the measure of an angle, I will put a lowercase m, then the angle symbol, and then I will use the equal sign. If I'm just like up here, if I'm using these, that is going to be more for congruency, where I'm not going to be talking about the value, just more about the angle itself. So simple idea of part plus part equals whole. So let's try an example. It says given that GFJ is 155 degrees, find the measure of GFH and FHJ. So let's take a look at GFJ, all these letters. They're telling us that the whole thing from here to here is 155 degrees. And so we are going to use this angle addition postulate to set up an equation. So it says if I were to take the measure of angle GFH, which is this one right here, if I were to add it to this angle here, the measure of angle HFJ, it should be equal to the entire big one, which is the measure of GFJ. All right, so let's sub in some values of what we know. When I'm looking at this blue angle over here, they tell me that it is 4x plus 4. I'm going to substitute what I know in for HFJ, which is this green angle over here, which they say is 4x minus 1. And it is equal to the entire angle, which is 155. So now that we are here, we just have a little bit of like terms. I see I have the 4x's in common. I also have those constants right there. So I'm going to combine like terms to get 8x plus 3 equals 155. I'm going to take away 3 from both sides to get 8x equals 152. And my goodness, I'm actually going to have to divide that, which I'm going to get a calculator out for myself right now. So divide by 8, and I'm getting x equaling, and give me 1 second here. So 152 divided by 8, I get 19. So I get x equals 19, but that is not our final answer. Reminder, they want the measures of these two right here. So I'm going to come over to the side. And if I'm trying to find the measure of GFH, so GFH is this one, that'd be 4. Instead of x, I'm going to put in 19 plus 4. So that's what I'm doing here. And for this one, I need to do 4 times 19 minus 1. So if I were to do 4 times 19, that is 76, plus 4, which is 80. And then over here, that would be 76 minus 1, which is 75. Also, please realize that when I add up, when I add up 80 and 75, I do get 155. So for our final answers, I'm going to have to find a spot for it. I have the measure of GFH is equal to 80, and then our units is degrees, and the measure of angle HFJ is equal to 75 degrees. So those are our final answers right there. I might clear some of this to make it easier for you all to see. Okay, just a couple more definitions and then some examples. Congruent angles, again, like our congruent segments, are two angles that have the same measure. We talked about with congruent, we think same. Also a reminder with congruent, we have that symbol. So if we were to have two angles that were congruent, there's a couple things we need to talk about. So if I had this angle that is congruent to this angle here, just a sketch, and I wanted to name them. So I have, let's call it angle A and angle X. There's a couple things. First, I could say angle A is congruent to angle X. And the second thing is in our picture, we want to make sure that we can notate. So what we do for our notation is we give little arcs to say, hey, those two are congruent. And it's kind of like tick marks where if I add 2 here, that's fine. So I could say, okay, 2, and you keep going as much as possible. And the reason why we do that is so if we have another pair of angles, just to quickly sketch, that are not congruent, we could give them 1 and still show that our original 2 are congruent to each other. Okay, so example 5, identify all the pairs of congruent angles in the diagram. So I see immediately with P and N, they have the same the arcs. So I can say angle P is congruent to angle N. I also see up here that angle L and M have the same number of arcs. So I could say angle L is congruent to angle M. All right, which brings us to our last definition and example. Our first one is angle bisector, which says a ray, again building off of those terms, that divides an angle into 2 congruent angles. So congruent, they have the same measure. So you can see here, this is the ray they are talking about, and it is dividing it into 2 congruent angles, and we can see the 2 congruency arcs that are showing it. So here what we know from that, what we can get from knowing that we have an angle bisector, is that we know that angle XWY would be congruent to angle YWZ. So yeah. And another thing we can get from that, I just real quick, if we know 2 angles are congruent, then we can also say that the measure of angle A would be equal to the measure of angle X. That is something that we know. All right, over here, our last one, it says in the diagram below, KM bisects LKN, and MLK, or LKM is 78 degrees. Find the measure of LKN. So let's just first see what the heck we're talking about with LKN. We want to find LKN, and what we know is that KM, this guy right here, comes in and he bisects it. And by bisects, he cuts in half. And they also give us here that LKM is 78 degrees. And if it's being cut in half, and I can see that this arc here, and we got 1 arc here, so if that's 78, then this would be 78 as well. And so to find LKN, I would just simply add those 2 together. So for 78 plus 78, I'm just checking with the calculator to make sure I do not make any mistakes, and I've got LKN, the measure of LKN, equaling 156 degrees. All right. So a little bit of a longer video there, but that is the final answer and the final example for us. So